Hello students, now let's look at parabola, which is the last conic for this unit. We have two kinds of parabolas which are either opening upward or downward as you see here, or they're opening sideways either to the right or the left. So if we'll just consider this for now. If you see in the quadratics unit from last year, we just know that y equals x squared is this parent function for quadratics, and the square is on x, and when the square is on x it means that it's either opening upward, or if it is negative x squared it is going to open downward, right? That's the information we know. And this is something, opening sideways is something that we did not consider because we were talking about functions at that time. And a vertical line test will pass a function when the line crosses the curve in only one point, right? That happens with the upward or downward curve, but not the sideways. Here the vertical line test will fail, obviously. But here we are not talking about functions, we are talking about conics. So when we are considering conics here, the upward or the downward parabola is given by this kind of equation. The square is on x, the x squared term is usually on the left side of the equation. The square is on x and the y is on the right side. The h and k give the vertex here. So this is the vertex form. H is always attached to the x, always attached to the x. So here the x is on the right side doesn't mean that this is going to be your h. So don't get confused with that. It's a common mistake I see. So h is attached to the x, k is attached to the y, right? So here the vertex is h and k, and the information that we can decipher from 4p is that the focus is always on the inside of the curve, right? We have seen in all the conics. Even in hyperbola, the focus was inside the conic. So which means this vertex, it's if the curve is opening upward, the vertex is below the focus, right? Or I should say focus is above the vertex. If it is a downward parabola, it will be the opposite. Focus will be below the vertex. So you have to be careful with those things. And p being the focal distance, the other side of the vertex within the same distance p is going to be the directrix. This is the line which is exactly at equal distance of the focal length, but it is away from the vertex, right? So if it is a sideways parabola, it's the same principle still. The focus is still inside the curve. The vertex is exactly between the directrix and the focus. So the directrix is vertical this time. Directrix is a line, so we must give it an equation but not a point or a single value. So we have to write the directrix equation as either y equals in this case or x equals in this case. Okay, so for p here, if you see here, this distance, the line that passes through the focus and hits the parabola in 2 points, right? That line is the latus rectum, and the distance from here to here is 4 times the focal length, okay, 4p. And that you can directly decipher from the equation because x minus h squared equals 4p times y minus k. And of course the last one is axis of symmetry, which passes through the focus and the vertex, right? Now if p is negative, the parabola is going to be downwards. In the case of sideways, it's going to turn left side if p is negative. Okay, let's do some examples and it's much more easy to decipher. So here we have, I'm going to write the equation of the parabola here so it will be easy for us to compare. So obviously in this particular equation, h and k are 0. So the vertex is at the origin. And 4p is positive. 4p is 12 and it is positive, so the direction is upward, it's opening upward, and P is 3, right? So P is 3. So to find the other details, we have to draw the curve. So here 0, 0, that's the vertex, and the axis of symmetry is the y-axis. This is the axis of symmetry also. Symmetry, right? So on the y-axis, P is, the focal distance is 3, so the focus is 3 units above the vertex because it's positive. The curve is going to be upward. So it's 0, 3. So the focus is 0, 3. And the directrix is 3 units below. So the directrix would be at y equals -3. So the equation of the directrix is y equals -3. Now to draw a parabola, we got all these details, but we need to draw the graph, right? So to draw, we just need 2 more points. Normally to draw a parabola, we need 3 points. So the other 2 points can be obtained from the 4P, which is the latus rectum, right? So it passes through the focus, and it is equally the focus. This focus is exactly in the middle of the latus rectum, meaning 6 units, because it's 12. The total length of the latus rectum is 12, so 6 units to the right and 6 units to the left will give you the other 2 points that you need to draw the graph. So this is at 6 and 3, and this is at -6 and 3. So all we have to do is join the points and draw, and hence the parabola. So you could draw the line passing through, that's fine. So that's the latus rectum, right? It's 12 units in length, and that's it. That's your graph. This is the parabola that we are looking for. So let's look at this question. Y minus 5 squared equals 4 times x plus 1. So be careful here. The h, the x-coordinate of the vertex, is here. So this is compared with this standard form, 4p times x minus h, which means that h is -1 and k is positive 5. 4p is 4, which means p is 1. So the distance, focal distance, is 1. And -1, 5 is here. So we need to draw the axis line, the axis of symmetry, which is horizontal this time. So it's going to be a sideways parabola. 4p is positive, so definitely it's going to open right side. So 1 unit to the right of the vertex will be the focus. So the focus is on the axis line, which is 0, 5. Okay, so the focus is at 0, 5. Vertex is -1 and 5, and the direction is it's opening to the right, right? And now we just need to draw the graph. So we need latus rectum, 4p is 4. So from the focus, 2 units above. 2 units above and 2 units below, right? So 2 units above, 2 units below, which means that this is going to be 0, 7, and this is the focus. This is the latus rectum endpoints, and 0, 3, right? So yeah, so this is the parabola. But we need to draw the directrix, which is 2 units to the left side of the vertex. So this is going to be at -3. Actually 1 unit, not 2, my bad. It's just 1 unit. So it's going to be here. -2. So the equation for the directrix is x equal to -2. Okay, this is it. This is the parabola. We'll quickly convert the standard form to the vertex form. You have to see the square is on x, so let's write our goal first. This is how we want, sorry about that, we want the equation to be of this kind because the square is on the x. So we have to adjust few terms, subtract the 8y on both sides. So finally you'll get x squared minus 4x, let's put the blank, equals 76 minus 8y. Okay, we want the y to be on the right, correct? So to fill the blank here, half of 4 squared. So we added 4 here, so we're going to add 4 on the right also. So the equation now would be x plus, actually I don't know why I put minus, x plus 2 squared equals negative 8y plus 80. There is a reason for me to write the y term first, and now you would factor the negative 8, right? That's it. So your center or the vertex here, vertex is going to be negative 2 and positive 10. For P is negative 8, so P is negative 2. So it's obviously an upwards or downwards direction, so vertical one. So it's going to be downward because it's negative. So H is negative 2, K is 10, and P is negative 2. So first locate your vertex. Negative 2 and 10 is going to be here, and negative 2, 10. And focus is going to be below the vertex because it's negative. So focus is here, which is at negative 2, 8, negative 2 and 8. And the directrix is going to be above this, 2 units above. So it's going to be somewhere here, y equals 12. So directrix is y equals 12. And we need 2 more points. For P is 8. Yeah, it is negative 8, but 8, the total length of the lattice rectum is 8. So on the focus, you have to go 4 units to the right, which is here, 2 and 8, and 4 units to the left, which is going to be negative 6, 8. So just draw the curve. That's the lattice rectum, and that's the directrix. Right? That's it. And this is the focus. Alright, so you can easily decipher information from the last example here. The vertex is, you can pause the video and check your answers after. Direction is right. The focus is obviously at 2, 0, meaning the focal distance is 2. The directrix is on the left side of the vertex, so x is equal to negative 2 is the directrix. The vertex is at origin, so it's going to be plain simple y squared without h and k. So it is 4p equals 2 times this, right? Sorry, 4 times p, which is 8. So it is going to be 8x. So that's the equation. All right. This is it, my dears. This is the parabola conic that you need to learn, and the math Excel questions follow through. You just have to do those questions. They're really simple, only 7 questions for the homework. All right, I'll see you next time. Thank you for watching.